ये सर आप लाइव है सर। सर आप लाइव है सर। तो कैमरा नीचे कर लीजिएगा सर।
हाँ, नीचे कहाँ बोलूँ? नहीं, मेरा दिख नहीं रहा है क्या?
दिख रहे हैं सर।
हाँ हाँ। नहीं, क्वेश्चन मुझे यहाँ पे भी दिखेंगे क्या?
सर यूट्यूब पे दिखेंगे सर आपको।
यूट्यूब पे, हाँ। ठीक ठीक ठीक। Yeah, so again, hello everyone. So maybe you can ask your questions if at all. So I see one comment by Ellen Arun. Uh, yeah, so you want to ask any question, Ellen? Okay, yeah. So maybe you can start now. So the first question is, does one rather use ARIMA models or cold winters, or better to check both? Yeah. So yeah, generally what happens is if you have some correlation, right, then it's always a good idea to go for ARIMA. But again, what generally people do is they sort of try to fit using both. So both ARIMA as well as cold winters, and then somewhere down the line they compare. So how do you compare using some standard metrics, right? Like let's say root MSE or MSE, etc. Okay, but let's say if you assume that there are some correlations underlying the data, then it's always a good thing to start with ARIMA and then maybe add on using hold winters or just holds or something like that. Yeah. Okay. There's one more question. So we have a small doubt in smoothing process. So is there any relationship between forecasting models, ARIMA, SARIMA, and smoothing techniques? Okay, so I think there's small confusion here. So mostly what happens is smoothing is kind of used for forecasting, right? I mean, before you go ahead and then do the forecasting, you require that smoothing kind of a process. All right. So let's say all these smoothing ideas that we'll be discussing in the notes. So let's say moving average or EMA, holds technique, hold winters. So essentially, what you're doing is you're trying to capture the data set using some appropriate model, and then in this case, the model is called as nothing but the smoothing process. And once that smoothing process is in place, then you can go ahead and then start forecasting. All right, so ARIMA, SARIMA are kind of the actual names of the models. Whereas when you apply some sort of a smoothing kind of an approach, let's say using SMA, EMA, holds, hold winters, etc., on some actual data, then the last stage is more like forecasting. Okay. Uh, so relationship between Arima, Sarima and smoothing techniques is you do have a relationship. For example, Arima, Sarima are the actual models, and smoothing techniques like SME, AME, etc., which I just mentioned, are more for forecasting. Right? Yeah, probably there's one more question. Does smoothing used to make model more stable? Yes, kind of. Yeah. So what smoothing does is, let's say, if you have some real data, right? And then let's say if I take an example of, let's say, simple moving average smoothing. So essentially what you're doing is you're kind of capturing the behavior inside the real data by some suitable smoothing technique, let's say SMA, EMA, or something like that. And then ultimate goal is to reduce noise. So reducing noise is more like, making the model more stable, or you're kind of ignoring all the random movements and so on and so forth. Data set on which you provide R codes available where, yeah. So again, I think there was one week when I sort of forgot to share the data, but then later on I did share the data. But moving ahead for all the other weeks, I think all the data sets are inbuilt. So when I say inbuilt, you have to basically take it from R directly. So you basically load a package, and then probably all the data sets are kind of inbuilt in R. So you basically call the data set and then start working directly. Okay. Yeah, thanks, Akhilesh, for good motivation again. Uh, could you please coding session for an entire week? Uh, yeah, I think that'll be slightly too much. Too much in the sense that so my plan is to cover some theory and then one complementary session where you basically bring in R, etc. Right? Yeah, probably what I can do is maybe I can share some material if required. So, at your own pace, you have to basically study the material that you see in R, unfortunately. I mean, maybe through some other resources, something like that. Right? And again, keep practicing the same code because, again, like I said, the codes are not different from what we study in theory that week, right? So don't leave the coding environment until you're basically convinced of each and every line in the code and so on and so forth. Can you give one small part in your lecture series on analyzing complex time series like EEG or ECG data? Okay, all right. Yeah, so maybe down the line, I'm not sure if you're if you yet received the lecture notes on spectral density. So maybe down the line we'll go ahead and then try to again elaborate spectral density. Right. So spectral density is probably one application is what you're mentioning. So how do you capture the frequencies? All right. So let's say if you transition from time domain to frequency domain, then things are slightly different because then you have to again incorporate some wave kind of a pattern and so on and so forth. Okay. So I think the application that you're mentioning, EEG, ECG, they'll again come back during that week. Uh, so Aditya is asking what should be the minimum number of observations required for forecasting using ARMA and ARIMA? Yeah, I mean, essentially, sample size is always a problem, and nobody has a concrete answer to that. But so let's say at least there should be some. So if you go past in the history, uh, so let's say if you have monthly data, so there should be at least data for let's say 1 year. So 1 year means 12 months, right? Something like that. Or if you're working for daily data, then let's say you have to go back for let's say at least 30 days or 50 days, something like that. So this is a standard technique. But again, if you don't have that much of real data, what people do is you can always simulate, right? So you keep whatever real data you have, and you basically simulate from an appropriate model which could be fitted on the data, and then try to extend that data. Right? Yeah, for that I mean EEG or ECG should be in wavelet. Yeah, but again, we'll not enter into wavelets because wavelets is kind of an electrical engineering concept, right? So we'll restrict ourselves to let's say frequency domain. Okay, so wavelets are kind of similar to frequency domain. I mean, wavelets is one application where you require transition to frequency domain, etc. Spectral analysis, yes. So I mean spectral analysis, yes. So there, I mean, if not EEG, ECG particularly, but we'll have a lot of similar applications and some more examples. All right, because each and every time series can't be dealt with using frequency domain and all those ideas, right? Uh, yeah, can we use integrated likelihood approach for estimating the parameters of ARMA model? Yeah, but again, estimating parameters of ARMA, why do you require some fancy modeling technique, right? I mean, simple MLE solutions are there, basically, isn't it? So for a simple model like ARMA or even ARIMA, one can actually write down the estimates using pen and paper also. So why do you require to go for integrated likelihood? I mean, stick to maximum likelihood. I mean, the standard of MLE that we study, right? And I think that should be enough for ARMA. If a data set fits both AR and ARIMA ARMA models, then okay, then which model should be used? Yeah. So this is a good question. In fact, so what happens is again, like I said, a lot of times what might happen is that there might be multiple models which might be suitable for a data set, right? So in this case, what people do is you fit both the models. So you fit one sort of an AR model and then maybe ARIMA ARMA model, and then compare. So compare what? So compare the forecasts. So let's say you do the entire exercise, you go ahead and then do the forecasting also, and then compare using some standalone techniques such as mean squared error or root mean squared error and so on. So whichever model gives you lower MSE, that model is better. Okay. So can we add other variables, extra information variables in time series other than time like regression for better forecasting? Yes, yes. So such models are called as Max, by the way. All right. So again, at this stage, if you're interested in more about those kind of models, so maybe you can give a brief reading about Max model. So Max means you have an ARIMA model and plus that X stand for exogenous variables. All right. So you create the ARIMA structure and then you also bring in some extra predictors in that case. Yeah, how can we check the accuracy of a forecasting model? Yeah, again, like I said, accuracy can't, I mean, this is not a machine learning thing that we're doing here. So time series falls under parametric or sort of explainable stats models, right? So accuracy is similar to you find out the mean squared error of that model or root mean squared error of that model. So that MAC should not be very, very large, isn't it? And then all these ideas, let's say comparing MACs or comparing root mean square error. So all these are useful for, let's say, picking the better model or uh, you know so these ideas. Yeah, so how to correct the bias based on the live actual data? So firstly, what do you mean by bias? I'm not sure entirely, but I mean, let's say if you have some live data and then you want to sort of model that using some time series approach, then you have to again go through the entire exercise we've been following through all the weeks. I mean, let's say choose some base model, then try to extend that to, let's say, probably Sarima, those kind of models. And automatically, once you find out the best model, it will automatically kind of reduce the bias. So you don't have to keep a track about the bias separately. Make sense? So, I mean, correcting the bias is again on the go. Right. Okay. So Suma is again asking, so for better fitting in every case, should we compute MSC? Yes, yes. So at this stage, MSC or root MSC. So these are some standard techniques. Okay. And as of now, if down the line we'll take a course on machine learning, let's say. So machine learning again has all these yardsticks, MSC, RMSC, and then probably a couple more. So May and all that. Okay. What is meant by the term drift in ARIMA? Yeah, in the ARIMA model. So drift is nothing but, let's say, I mean drift. So think of drift to be similar to a an intercept in the model. Okay, so let's say intercept means what? So intercept means some overall mean, right? So let's say if that overall mean is, let's say, 10. So that intercept 10 means that you have a drift in the mean value. All right. So ARIMA plus a certain intercept value, which is, let's say, 10, for example, which is a constant. Okay, so that intercept is kind of similar to a drift. Uh, so to deploy the models in production, what is the best way for Python R? Yeah, again, it entirely depends on what you're comfortable with, right? I mean, I personally use R, so I've been teaching using R. And again, all these examples, you don't have a big data, isn't it? So time series models, you can't have a big data. I mean, of course, you can have a big data, let's say minute by minute data, something like that. But let's say all the applications we're dealing with in class is we have a smaller chunk of data, which could be equally or rather slightly better modeled in R, because R has all the inbuilt packages, time series packages, and so on and so forth. Right. But again, if you're comfortable in Python, transitioning from R to Python is not difficult. So if you want to be consistent, I mean, let's say translate all the codes from R to Python and then run this. Yeah, I think Mahesh is asking a good question. So if you have a data for 100 days, how many days can be forecasted based on the previous 100 days? Yeah. So again, generally the forecasting window should not be very long, isn't it? Because what would happen if the forecasting window is too long is that eventually the forecast would converge. And that you don't want, right? I mean, let's say if you keep the window to be, let's say, the next 50 days, it doesn't serve the purpose, right? I mean, if you have data for only 100 days, so why would you want to forecast for the next 50 days? Okay, so ideally, if you have data for 100 days, forecasting could be, let's say, at the max 10 days or for a week or something like that. All right. So that all the forecasts don't converge to a point. So you get some, what do you call it, variance among the forecasts also. You know. Can you please suggest some more real world projects based on this course? Yeah, of course. Yeah. I mean, probably it would be a good idea if you can just provide me a small background of yourself. Is that, I mean, are you looking on particular area or something like that? Because I mean, your time series can be applied in almost all the areas, and I think we discussed in the very first session also, right? So if you can just tell me whichever area you're more interested in, then probably I can suggest something. Is selecting an optimal value of beta and gamma in triple exponential smoothing similar to that of selecting optimal alpha value in exponential smoothing? Yes, yes, yeah. So the only difference is triple exponential smoothing is an extension, right? So rather than a single parameter alpha, you have these added parameters beta and gamma. Okay, but let's say if you're implementing a code in R or any software, it will automatically find out the optimum values of all the unknown parameters in that model. Okay. Yeah, sir, finance. Yeah. So I think the question was asked by somebody else, but I think the answer. I mean, okay. So I think again same finance, stock market as well as for marketing. Okay. Yeah. Yeah. Sure. So finance. I mean, lot of real world applications. I mean, let's say stock price forecasting is one. But again, just a small disclaimer that I mean, you will see a lot of time series papers and then analysis, research being done on stock price forecasting, but nobody has come close to forecasting, which is really good. Okay, so this could be a starting exercise mode. So stock price forecasting, cryptocurrency forecasting, or let's say exchange rate forecasting, right? All these. So a simple exercise could be, let's say, if you take a stock, let's say Reliance or HDFC, whatever, and then down the line try to forecast it using some Arima model and then see what the results are you getting. All right. Or let's say finance, it's slightly hard to bring in seasonality. So if you want an example of seasonality, let's say temperature data, rainfall data, humidity data, all these are good examples where seasonality can bring in. So there you can apply Sarima techniques, isn't it? Or probably finance, one more example would be, let's say, loan claims. You want to find out the progression of, let's say, loan claims, or you want to forecast the value of the loan claims, right? So if you get an actual data about loan claims, then you can apply some ARIMA techniques or Holt's approach, Holt Winters approach down the line, and then try to forecast that for the next week or next month, something like that. Okay. How to deal with missing values in time series data? Yeah. So again, missing values, as in how you deal with in any other stats course, right? So probably you can impute it. So imputation means what? You replace the missing values with average of the nearby values or something like that. Okay. So let's say if you have some missing values in between, you can take the average of the entire month. So let's say if you have daily data, then maybe average over the entire month, and whatever average you'll get, you simply replace that average in the missing values. Or if you have just a handful of missing values, you can again ignore this. Right? Okay. Climate effect on BBD, yeah, kind of. So all these are applications. Suppose we have data for several years, and among those years, some data on successive years is missing. Then how can we model such data? Yeah. So again, like I said, one can impute those missing data points, right? I mean, let's say again, if you only have a handful of years where data is missing, then maybe again find the average of, let's say, the nearby years. So one prior, one after. Simply average that, and whatever average you get, replace it in the missing data, so that you're basically filling the missing data with some concrete values. Make sense? Correct. So missing values can be dealt with interpolation. Yes, also. So average is just one very easy idea of interpolation, right? But again, what you can do is, let's say you can create some simple regression sort of a model, and then try to replace the missing values by plugging in the values of all the other predictors and finding those responses. So this is what is interpolation, isn't it? So is it safe to say we should not rely on time series only for stock prediction until now? Yeah, so of course you should not rely on time series entirely. Yes, because again, now given the advancements of technology and all that, I mean, people have been using deep learning, neural networks, all these ideas extensively. So simple ARIMA, or let's say hold meters won't do the job, right? Because these are at a very linear stage. Okay. By the way, in the course down the line, we have an entire module on non-linear time series. So people try to apply non-linear time series on, let's say, stock price forecasting, something like that. Yeah. When working with a data set, when should we use the MA model and when should we use the AR model? Yeah. So again, just by looking at the data set, nobody can see, isn't it? I mean, at the end of the day, it's a sample. So by looking at the values, I can't say that which model would be better. So you have to again do the entire exercise sincerely. All right. So let's say try to fit some ARMA model, and that ARMA model will tell you that what the orders are of the ARMA model, isn't it? So P and Q. So depending on what orders in the ARMA model you get, that would be a best model according to, of course, some criteria. So let's say least AIC, or and I think we've been discussing all these ideas in the notes also, right? Okay. Now again, difference between AR and MA model, theoretically we can say. So AR model is, so what is an AR model? AR model is something where the current value depends on its own historical values. All right. So YT depends on YT minus 1, YT minus 2, etc. And similarly, what is MA? So MA is slightly different, where the current error depends on, or rather, the current error is the average of all the past errors. Okay. But again, practically speaking, we can't say that whether MA model would be better or AR model would be better and so on. Because generally speaking, MA models are more like stationary models. Okay, so if your real data set, if you're seeing that the data set is highly non-stationary, then obviously MA model can't be used. Okay, so this is one way of ruling out probably. Make sense? How to deal with seasonality when the seasonal period is not fixed? Yeah. So again, like I said, try out a few values, isn't it? So and again, there has to be some common sense involved here, or maybe some expertise knowledge required. So let's say if you have temperature data, okay, so temperature data is assumed to be, let's say, seasonal with a period of 12. So temperature in January repeats in the next Jan and so on, right? So hence you can sort of fix that seasonality period. Or let's say if you have sales data for a store. So sales data, let's say seasonality could be weekly, you know. So sales on Monday would repeat on the next Monday, Tuesday on the next Tuesday, so on. So if you're not very sure as to what the seasonality period is, then try fitting some models with different values, right? So let's say 12 or 4, 52, that's it. Okay. And again, like I said, how do you compare? So you compare using whichever model is giving the least MSC. Right. All right. Yeah. So if you have any more questions, maybe you can take them. Yeah. So so I can see one more. Suppose we have 5 successive years missing data, then as per you say to take average of prior and after years, then can we fill same average for the, yeah, again you do things slightly. So maybe what I'll do is, let's say if you have 5 years of missing data, right? So let's say take the average of 1 year prior, 1 year post, replace that average in the first year which is missing. And then now we have some updated data. So again, take the average of that point and probably either or, and then replace. So this you can do, isn't it? So rather than replacing the same value everywhere, you can take multiple averages of as in how the data gets updated and replace them. Right? What is the difference between error used in MA model and residual error used for diagnostic checking after model fitting? Nothing, probably nothing. So again, like I said, MA model is the base model in the MA model is the error, right? And that error is exactly same as the residue. Okay. So in the MA model, what you're doing is you're basically averaging the errors and then creating that model. So XT is nothing but epsilon t plus epsilon t minus one into one half, whatever, right? So that epsilon t or ET, whatever. I'm forgetting the notation, but that epsilon t or ET, they mean the same residual error. Right. So once you sort of fit any other model, right, then you can sort of look at the residuals or nothing but the errors produced by the model, and those errors and these errors which are kind of used in creating the ME model, they are kind of similar. Okay. All right. So anything else at all? So the number of people watching, it's kind of fluctuating, but so currently I'm seeing 26. Okay. But then yeah, now I think they're dropping. Yeah, can you please share what is the latest in time series as well as the latest work like to share? Yeah, sure. So yeah, again, like I said, time series is kind of very much evolving, firstly, right? So integration of let's say time series models and some ML techniques, right? So such models are called as hybrid models. So how do you improve forecasting? So the very last week, in fact, in this course, I'll be giving a flavor of neural networks and then link between neural networks and time series. Okay, so that part is ever extending. So let's say other deep learning techniques or let's say reinforcement learning, right? So even all these ideas I'm trying to do in my current research also. So how do you implement, let's say, a simple ARIMA model and connect a simple ARIMA model with, let's say, neural networks or deep learning techniques or reinforcement learning techniques, etc. So for that, the data set is very sort of a complex data set. So by complex meaning that let's say a lot of non-linearities and lots of different patterns, jumps. So how do you model jumps, let's say? So far in this course, we haven't talked about jumps, right? I mean, you were talking about, let's say, continuous time series. But when you talk about stock prices, you may encounter some jumps. So let's say, for example, the market closed today, and then tomorrow, if you see a gap up or gap down, right? So that gap up or gap down will create some jumps. So how do you capture the jumps, or you know? So for that, you might require some slightly advanced time series techniques and so on. Basically. What are the names of the models for jumps? Yeah, again, so modeling jumps, you have a lot of different stochastic processes, right? So what people do is, let's say, so some of the names of those stochastic processes are, let's say, Heston models or Hawk's processes. So I'm not sure that how much familiar are you with stochastic process, Brownian motion, or all these concepts. But again, let's say all the extensions of some inbuilt stochastic processes like Hawk's process or some similar processes. So these have a capability of modeling jumps. All right. So time series is what? Time series is a stochastic process. All right. So if you bring in, so rather than ARMA, what we're studying in this course, let's say if you start by studying, let's say, for example, a Hawk's process or some other extension of Hawk's. So then probably you might be able to model the jumps also. So can you, my background is in MLDL, right? So can you please suggest some pointers as in which direction I should move so can better take advantage of time series? Yeah. So again, I mean, if your real data is time series data, right, then you have to apply some time series technique, isn't it? If your data is not time series, then it's all the things we're studying in this course are out of question. But let's say if your real data contains some variable, so you're basically recording observations over time, then you can sort of implement all these ideas. And again, like I said, hybrid model. So maybe spend some time on, let's say, reading about hybrid model. Because hybrid means what? You have some parametric model, like I said, ARIMA. And how do you connect ARIMA with, let's say, neural networks or deep learning or something like that? All right. So again, moving ahead, probably if you will focus on these slightly advanced techniques. Okay. So again, like I said, in the last week, we'll discuss one NNAR model. So, I mean, since all of you have exposure to AR model, so how do you connect a simple AR model with neural net? So then the idea would be NNAR. So neural network based AR, right? So try to read more about, let's say, specific models which are applied in finance, right? So area wise also models depend or they kind of change. So same model that you'll apply for, let's say, high frequency stock price forecasting may not be applied for, let's say, examples like ecology or other areas, right? Okay. So in which direction you should move is read more about, let's say, hybrid models or some connection between some parametric models and some ML models. Right? Yeah, so please refer to some reference book for time series. Yeah, so I think so. In this course, did I give you some names? I mean, probably I can list down a few names, or maybe what I'll do is I think the best thing. Just hold on. So yeah. So by the way, this is a very good book, right? Uh, so this is analysis of financial time series. All right. So can you see that? Probably not, right? Ah, I think now. So analysis of financial time series by Rui Say. Okay, so by Ruiz, say maybe you can take a screenshot or something. So people who are interested in financial time series, I think this would be a good book to have. All right, and apart from that, couple of other books I can mention. One is by Shamve Stouffer. So just take a note. So time series and applications by Shamve Stouffer, and third book is Brockwell Davis. Okay. So even if you read some chapters out of these three books, I think that should be good. Is there any method by which we can forecast wind speed at a particular time in a day in advance? If yes, yeah. So again, probably yeah. So again, like I said, if you have some wind speed data, right, try to start with ARIMA modeling, Holt's method, all that. Okay, and then as in how the course progresses, then you can again bring in some non-linearity into play or something like that. So what final model could be applied? Even I don't know, right? I mean, again, like I said, that wind speed data is a sample data. So which model suits the best? Even I'm not sure at this stage. But then exercises kind of similar to what we've been doing in this course. So try to fit some Arima model maybe, because if wind speed is kind of seasonal, it might be right. The wind speed might be seasonal. So maybe try to apply Sarima model, then Holt's approach, Holt Winters approach, etc. What are the advantages and limitations of using ML models over traditional time series model? Yeah. So very big. Oh, you're saying yeah. So advantages is again it can capture a lot of other non-linearities, isn't it? So Arima is what? Arima is a very linear model. So if you have a lot of complex patterns and then let's say a lot of jumps, like I said, right? So then Arima can't do a good job. So for that you require some ML techniques. And one more advantage in ML is you can bring in some extra variables very easily and then do that feature engineering, all those things, right? And one disadvantage or limitation, like I said, ML models are not explainable. So ML models are black box models. So you don't know what's going inside the black box or what's going inside the model, right? As opposed to let's say Arima. So Arima, I can actually write down the complete model on using pen and paper, right? So in that sense, Arima is much more explainable. Or let's say if you want to translate or rather transfer that model or all the analysis you've done to some other person, then it will be difficult if you are using an ML model. But it might be very easy if you have a explainable kind of an Arima model. Okay. What is difference between recurrent neural network and time series? Yeah, yeah. So again, RNN and time series are completely different branches. So like I said, hybrid model. So these hybrid models they connect these two. So time series is what we are studying in this course. So time series is standalone statistical approach or more like fundamental approach to analyze data. Whereas RNN is one kind of a neural network model. That's all. All right. So time series and RNN have nothing to do in common. So these are two different approaches. Right. Okay. How to prevent overfitting and to manage model complexity? Yeah. So I mean, once you create that hybrid model, probably your question is more from an ML point of view, I suppose. So once you create that hybrid model, similar to how you handle any other ML model, you do that. So the error in the test data should be low, you know. And if you think that overfitting is happening, then maybe you are kind of bringing in some unwanted predictors or let's say unwanted features, right? So you might want to correct those, might want to remove some of those, standardize some of those. So all the standard techniques that people use in ML can be replicated. Explainability is the issue with DL models. Yes. So again, like I said, ML, DL, RL, whichever model you use, explainable models are not there, right? So you can't sort of explain the analysis model to some other third person, something like that. Yeah. Okay. So shall we close this, or any other last minute questions or something like that? Yeah. So I'm practicing it in Python instead of R. Yeah. As it has been more relevant for my work as of now, if possible, please also bring a course on time series in Python. Yeah. Uh, I'll try to do it. But again, like I said, these days with the use of Chat GPT and whatever other alternatives, I mean, you can replicate R codes to Python codes, right? Easily. So follow all the theory, and then the last one portion that we're having every week, you can simply translate that code to Python code and then run. So since you're already saying that you're practicing the entire thing in Python, but yeah, so I'll take that as a good suggestion. So maybe down the line I can create or rather recreate the same course by bringing some element of Python. Okay, yeah. All right. Okay, so I think we'll close it, right? And then again, we'll probably have one more session maybe next month or something like that. Okay. So of course, by that time you'll have much more flavor about, let's say, some non-linear time series or frequency domain, as I was mentioning earlier, also, right? So some more slightly advanced techniques rather than Arima, Arma, and all. All right. Okay. Add some more modules even after this course. Maybe your YouTube channel. Yeah, yeah, correct. So currently I don't have a YouTube channel, but probably yeah, I'll think on that possibly. Okay. Okay. All right. So I'll close it now, and we'll meet next time.